So, good morning, everyone. So, here is your today's video lecture discussion on general chemistry 2. So, for today, we will continue our discussion on the basic hydrocarbons. No, so we are done with the alkane. No, so when we say alkane, no, it is a hydrocarbon that contains only single bond. And we are also done no, naming. No, how do we name alkane? So in this lesson, we will continue discussing about the alkenes, alkynes, and the aromatic hydrocarbons, and also how to name them or how to write the condensed or the structural formula for these hydrocarbons. So your hydrocarbons again, no, is mainly composed or the basic hydrocarbons that we have are the alkanes, the alkenes, the alkynes, and the aromatic. When we say alkenes, it contains at least one double bond in its composition. Alkynes, no, it contains at least one na triple bond in its composition. And then in your aromatic compounds, so these are the types of compounds that are cyclic in nature. No? So they contain two or more na mga double bond in its composition and thus forming a ring. No? So first, let's go to alkenes. So when we say alkenes, no, since alkanes, no, from the previous lesson, alkanes only has a single bonds, so they contain the largest possible number of hydrogen atom per carbon atom. So as a result, your alkanes are called as saturated hydrocarbons. So since alkenes and alkynes and aromatic hydrocarbon contains multiple bonds like double, triple, or even the localized bond, so as a result, they contain no lesser na hydrogen with an than an alkane with the same number of carbon atoms. So even though they have the same number carbon of same number of carbon atoms, but since there's an existing na double or triple bond, so these alkenes and alkynes is considered as the unsaturated hydrocarbons. So the whole unsaturated molecules are more reactive than saturated ones. Okay? Unsaturated sila. Dili sila daghan o gina-carry na hydrogen in their compounds. So alkenes, no, are unsaturated hydrocarbon that contain at least one double bond na carbon bond. No? The simplest alkene is the CH2 double bond CH2, or also called commonly known as ethene, no, or ethylene. No, so which plays important roles as plant hormone in seed germination and fruit ripening. So mo na siya nga um, chemical compound that is responsible sa paghinog sa ato ang fruits, no? Si ethylene. So this ethylene is an alkene. No? So the next member after ethylene is the propene or propylene. No? Mabantayan nato alkene, no, nag-end siya og ene, in. So if the substance contains more double bonds, so the location of each is indicated by a numerical prefix, no? Butangan na po nato siya og prefix na number. No? And the ending of the name is altered to identify the number of double bonds. No? For example, this one, we have CH2, double bond CH, single bond CH2, single bond CH, and double bond CH2. So it is named as 1, 4 dash pentadiene. So why pentadiene? No, we have 1, 2, 3, 4, 5 ka-carbon atom in its longest chain. And then, so that is why it is named penta. No? Now, asa ni gikaning 1 and 4? No. So this 1 and 4 indicates, no, this numerical prefix indicates where do we find the double bond. So since the first double bond can be found in the first carbon, so we have 1, no, na double bond dayon, so they have 1. 1, 2, 3, 4. So in the fourth carbon, naa na po'y double bond, so that is why naa na po'y 4 diraa. And then to identify how many, no, ka-double bond, we use the suffix diene, triene, and so forth, no? No, for example, para ma-identify nato ang ato ang number of bonds, double bonds. So that is why diene ang ato ang ending na name. So we have 1, 4 pentadiene. Okay? So we have this what we call isomer. So geometric isomer of your alkene. No? So since these alkenes, no, the two isomers on the right or on below, no, differ in the relative locations of their methyl group. So these two compounds, no, are called the geometric isomers. So these compounds, no, that have the same molecular formula and the same groups bonded to one another. However, naglahi sila sa spatial arrangement of this group. So for example, this one, no, si methylpropene, no, ingon anang iyahang orientation. No. Unlike this one, lahi po yung orientation, lahi po yung orientation diri. Although they have the same composition na CH, duha ka CH3, duha ka single bond, duha din ka CH, no, that is bonded with a double bond. No? Another pod kani siya is wala pod siya metal group na naka-branch. No? So different na branching, different position of your branches, no, it results to a different na chemical. No? And we call this, no, even if they have the same molecular formula but different orientation, we call that as geometric isomers. So we have this what we call the cis and transfiguration. No? So when we say cis figure of your molecular formula, so it means that the two similar na substitute compound or group is on the same side of the double bond. When we say strands, no, it means that the substitute na group is on the other side, opposite side of your double bond. That is why even though they are the same, no, na butene, but they differ in the location of the methyl group that is attached to your butene. So therefore, it has a different na chemical composition and thus has different na boiling point. Again, we call this type of compounds, no, they have the same molecular formula but different arrangement of your group as geometric isomers. Yun, cis isomer and trans isomer. So they possesses different na distinct physical property, no? So that they differ significantly from each other aside from their chemical behavior. Next, now if we have double bonds, we also have these triple bonds. No? So we call these hydrocarbons as alkynes. So alkynes are unsaturated hydrocarbons containing one or more carbon triple bonds. So the simplest alkyne is the acetylene. No? So see, C2H2. So this acetylene is a highly reactive molecule. So when this acetylene is burned in a stream of oxygen in an oxyacetylene torch, the flame reaches about 3,200 Kelvin. So very, very hot, no? Ni siya nga, chemical. So because alkynes are generally highly reactive, so they are not as widely distributed in nature as alkenes. So your alkynes, however, are very important intermediates in many industrial na mga processes. So gamit siya, no, in the society ng mga chemicals. So alkynes are named by identifying the longest continuous chain containing the triple bond and modifying the ending of that name of the corresponding alkane from ane to ine. No, alkyne. No, Y-N-E. So let's have the sample exercise. So let us name the following compounds in letter A and letter B. So in your letter A, it was stated in the structural, no, the basic structural formula of your hydrocarbon, whereas in letter B, it is in a condensed form. Okay, so you can pause this part of the video so that you can answer on your own and challenge yourself. No? In letter A, how many carbon are in there? No, in the longest chain. How about in letter B? How many carbon in the longest chain are there? Take your time trying to answer. Okay, so let's have letter A. Sample letter A. Sample exercise. So what is the longest chain? We have 1, 2, 3, 4, 5, 6, 7. So heptane. Heptine? Unsa man siya pagka-name? Now, since this is an alkene man, so this will become now heptene. So why did we started counting in this side? The counting of carbon number. It is because no, it is the nearest carbon no that is near to the double bond. So we have 1, 2. No, if we start in here, very far na siya sa double bond. Next, we have already identified that it's a heptene. No, because of the longest chain that has 7 carbon. Now, what's next? So let's identify the substitute group that is attached to your longest chain. So we have here CH3. So where is the CH3 located? We have 1, 2, 3, 4. So it is located in carbon number 4. So therefore, what would be the name of our um, hydrocarbon in letter A? No, it's heptene. The double bond is found in number 2, so we have 2-heptene. Next to that is the methyl group that is attached to your methyl carbon number 4. So we have 4-methyl-2-heptene. So what would be the geometrical configuration of that double bond? It's a cis configuration. No, since the CH3 in here and also CH3 in here are found in the same side of your geometric configuration. Okay, so the name of this is again 4-methyl-2-heptene. 4-methyl because 1, 2, 3, 4, the methyl group that is attached is found in carbon number 4, and 2-heptene because the double bond is found in carbon number 2. Napadi ay, ibutang paday nato ang iyahang configuration. So the configuration shall be placed the I no in the between the name of your substitute group and the name of your um, base carbon. So we have 4-methyl cis 2-heptene. So in naming no nagi dapat ng dash, no very important na si dash. Tingnan mo siya pwede isulat nga sumpay-sumpay. No, it will make your answers go wrong. How about letter B? So in letter B, we have how many carbon in here? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So either of the two, you have 6 carbon in your longest chain. So since it has 6 carbons, so your carbon compound derivative is named as hexane. No? Kaya di ba hexane kung alkane, hexene, ene pag alkene, and hexine pag alkyne siya. No? Y and E. So this is since triple bond, so this will be hexine. Now, the triple bond comes after the first carbon. So, making it 1 hexane. Diba? Nasa diri in the first carbon. Next. So, since the branch of the hexane chain contains 3 carbon atoms, 1, 2, 3. 3 man siya carbon atoms. So, kanang 3 carbon atoms, so it is a propane. Since it's a kuan man, in the triple bond, so we can also call propane as in the propyl group. So since it is in the third carbon, 1, 2, 3, that connected, so the name of the propyl group is 3-propyl. So the complete name now of this compound molecule is 3-propyl-1-hexane. Okay. Now, kindly pause again and try to draw the condensed structural formula for the 4-methyl 2-pentyne. Okay. So in writing, condensed formula, pwede siya nga ato siyang i-straight chain or pwede po nakatong normal na structural formula. Normal na condensed structural formula na ato yung i-clear asa ang branch out ani or nana. Pwede po siya nga katong super condensed na nga structural formula nga naka open and close parenthesis, ang ato ang branch off na groups. So in here, we have 4-methyl 2-pentyne. So it gives us the idea that the carbon group, pentyne, so it has 5 carbons in its backbone. Then, the triple bond could be found on the second carbon. And also, naa siya'y substitute na or group na sobra which is in methyl form. And this methyl is connected in carbon number 4. So, saan natin siya pag-draw? So, this condensed structural of the 4-methyl 2-pentyne could be written as this one. So, we have how many? Carbon 5. We have 1, 2, 3, 4, 5. Next to that is 2. It is found in The what do you mean? The third triple bond can be found in carbon number 2. So, writing the triple bond in the number 2 carbon. Padulong sa connected siya to carbon number 3. And then, the metal group is attached in carbon number 4. So, 1, 2, 3, and 4. So, that's your condensed structural formula. No? But it could also be written no, as CH3 dash C triple bond C dash CH open and close parenthesis CH3 dash CH3 if we want to write it in a straight chain na condensed structural formula. Okay? Next to your hydrocarbon is the aromatic hydrocarbons. So when we say aromatic hydrocarbon, no, it is a hydrocarbon that has a ring. No? So the simplest aromatic hydrocarbon is the benzene or the C6H6. So benzene is the most important aromatic hydrocarbon, and most of our discussion focuses on it. So kani siya, no? So we have benzene, so we have double ring, naphthalene, triple ring, anthracene. We also have toluene, where the benzene has a substitute group of methyl. Then we also have the pyrene. So these are all of these are aromatic hydrocarbons. So in aromatic hydrocarbons, we have this what we call the substitution reactions. So aromatic hydrocarbons undergo substitution reaction relatively easily. So in this substitution reaction, one hydrogen atom of a molecule is removed, no? Tanggalon siya o substitutan, alisdan, pulihan, no? By another atom or groups of atoms. Substitution reaction nga. Okay. So when benzene is warmed in a mixture of nitric and sulfuric acid, for example, one of the benzene hydrogen is replaced by the nitro group NO2. No? Kung ay mo siyang painitan, hintahay. So there will be a substitution na reaction that can happen to that benzene. And it could be written as this one. Mahimo na siya nga connected. No? Ang katong isa ka hydrogen niya. Kaya bali, kung atong i-write si benzene, no, structurally, mura man na siya, every corner of that benzene contains carbon. And every carbon na siya kauban na hydrogen. So we have C, 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 C. So in here, no, in your benzene, no, nga na siya kauban H, dira, ang isa ka hydrogen pair of that carbon is replaced with nitro group, no, NO2. So that is why, no, if a substitution reaction happened to a certain aromatic hydrocarbon, no, it will be renamed according to the group that ni-substitute atong hydrogen. Like in this example, no, ang ni-substitute is a nitro group. So it could be renamed as nitrobenzene. Okay. No? So in naming your aromatic hydrocarbon, no, there is this what we call different prefix for them, no, in naming them. So sometimes, no, there are, for example, in this one, no, there are three isomers of benzenes that contain two nitro groups, the ortho, meta, and the para dinitrobenzene. No? Although, no, bisan pag dili na siya nitrobenzene or nitrogen, nitro group ang kauban dira, but it is also applicable to other na substitute group that will attach to your benzene. No? Ato ang i-attach before the name or the prefix that should be attached, no, if two substitute is adjacent to each other or next to each other, Ang atoang i-prefix is ortho. Pag ang atoang benzene has two groups that is naailaghang na isa ka carbon, no, in between a carbon, no, na ay duha ka kuan group that is substituted, no, in the benzene. So ang ato ang ibutang na prefix is meta. However, no, if two groups are atbang sa isa't isa, atbang sila. So there is duha ka laghang in between them, no? Murag opposite lang sila with each other. So ang isumpay nato na prefix is para. Okay. So ayun. So these hydrocarbons, the alkanes, alkenes, alkynes, and the aromatic compounds are just few of those functional groups, no, that can be added or that can be found, no, in our environment, in the nature, and has a kanang murag complex na application in our lives, no? In the picture, in the earlier slide, no, kato siya, si octane rating, no, of your petroleum. So there are different na mga rating dahil sa gases, no? And that explains, no, that is nga naiuban gases na mas taas og octane rating pasabot mas efficient siya to use as a gas or fuel sa imuhang car or kuan, no? Because no, these gases, no, is a hydrocarbon man, no? It is composed of carbon and hydrogen, no? Isa na siya sa mga applications. So, kanis sa mga hydrocarbons, no, daghan pa ni sila mga kauban, no, which will be discussed in the next lesson, which is all about organic functional groups. So, that's all for this video lecture. Thank you for listening and thank you for being with me up to this moment of the video lecture. So I hope you have learned something and God bless us all. See you next meeting.